So let's take a look at some EKG rhythms and go through them and decipher them. So first thing we want to do is, what is the rate of this particular rhythm? Well, as we go through, we see that the rate is approximately 50. Are there P waves? Well, yes they are, but do they look normal? No, not really, because we have a peaked one there, it's smaller there, it's more peaked there. This one comes close to looking normal. This one doesn't look too bad either. Okay, so we have different looking P waves. The QRS is within normal width. The rhythm is regular if you measure it out. The PR interval, if we look at it and we measure it, and remember the PR interval goes from the beginning of the P wave to the beginning of the QRS, it is variable. Some of them are longer than others. As a result, this would be considered wandering atrial pacemaker because you have different looking P waves and everything else is completely normal. All right, on this next one, pause the video, watch it, see what you can come up with, and then I'll be right back to help walk you through it. So how'd you do? What'd you come up with? Well, let's take a look at it. If we look at the rate is 80 beats per minute, and we look solely at the QRSs as we're going across. Are there P waves? Well, no, they're not. We see that we have flutter waves here that look like a sawtooth pattern. The QRS is completely within normal range. The rhythm itself is regular, and because we do not have P waves, there is no PR interval. This, therefore, would have to be atrial flutter. And we can see that we've got 1, 2, 3, 4 to 1 conduction there. 1, 2, 3, 4 to conduction, 1 there. So it's fairly stable as far as the amount of rhythms or QRSs that are being generated by the ectopic foci. All right, here's another one. Pause the video, go through the steps, see what you come up with. So let's go through it. 6-second strip. If we count out all the QRSs there, we'll come up with a rate of about 210. Are there P waves? Nope. We don't see any. It's too rapid. They're probably buried within our QRS. The QRS itself, for the most part, is normal. This one looks a little different here, but that's one outlier. We're not going to worry about that. So we look at the entire 6-second rhythm. The rhythm itself is regular. If we measure it out, we'll see that it is regular. And because there are no P waves, we have no PR interval. Therefore, this is rapid, very rapid. It is regular. We don't see any P waves there. This is a supraventricular tachycardia. We know that it is originating above the ventricles primarily because the QRS itself is narrow. Supraventricular tachycardia, or SVT. Let's look at another one. All right, did this one throw you off? So let's take a look at it. We see our QRSs are kind of looking weird here because they're bizarre looking, they're different size and everything. But if we measure them out, we'll see that we've got a rate of about 90. If we look under the underlying rhythm or at P waves, we see that we've got F waves. All right, sawtooth pattern there as we're going through. The QRS itself is kind of weird looking and is multiform, but that really doesn't play into it there. Now we do have a slightly irregular type of rhythm there, and they're going to see why that is in just a moment. Because we have flutter waves, we do not have any type of PR interval, so it's unknown. We don't measure it. Now, this would be atrial flutter. The rhythm is irregular because we have variable conduction. As you can see, we've got 1, 2, and then a QRS. 1, 2, 3, and a QRS. We've got 1, 2, QRS, 1, 2, QRS, 1, 2, QRS. So it's going through and it's conducting in different manners and different forms. So here's another one. Pause the video, measure it out, and decipher it. Tell me what you got. Oh, let's go back. Okay, so let's look at it. What's our rate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 190. So it's very rapid. What's our rhythm? If we measure out QRS to QRS, Q wave to Q wave, we'll see that it is regular. Do we have P waves? No, we really don't. These are T waves here because they're too large. All right, so those are not P waves. Do we have a PR interval? Well, if you don't have P waves, you can't measure a PR interval. Once again, remember the P waves are probably buried within the QRS. Looking at the QRS complex, does it look upright and narrow? Well, yes, it's very narrow. Okay, so we would call it maybe 0.04 seconds in width. It's a rapid heart rate. It is irregular. And because there's no P wave that we would see there, this has to be supraventricular tachycardia, SVT, another one. Another rhythm coming up. Pause it, go through the steps, see what you come up with. All right, this puppy's a little different here. All right, so as we go through, we see we've got a rate of 1, 2, 3, 4, 5, 6, 7, 9. So we have a rate of 90. If we look for P waves, we see that we have fibrillation or tiny F waves right down in here. All right, there's no organization. Those are entirely different than flutter waves. They're not organized at all. It kind of looks like ventricular fibrillation along with a QRS. So we do not have P waves, but we do have F waves. The QRS is normal and upright, so we don't have anything as far as that's going on, and it is within normal width. If we measure this out, it is really, really irregular. Okay, so that's one of the hallmarks of atrial fib. It is generally always very irregular. Now, sometimes you can get into atrial fib that has a rapid response that is more regular, but this one is very irregular. Because we don't have any P waves, instead we have fibrillation waves. We do not have a PR interval. As we put all these things together, then it has to be atrial fibrillation. This concludes this lecture of atrial tachycardic atrial rhythms. Please make sure that you're going through your textbook and you're practicing the rhythms that are laid out within the textbook itself. Be sure to let me know if you have any questions.